Welcome to qnawire.
Hi, so over here we have the following reaction, C6H6 in gas plus 3 of hydrogen in gas are going to produce C6H12 as gas. So, first of all, let's check up why the answer that is given here doesn't make sense. Remember that this corresponds to the molar fraction is equal to the amount of moles that we have of the substance divided by the total amount of mole that we have. So we know that this reaction needs to go to completion, and if we have this molar fraction, that means that the fraction of hydrogen that we had initially of the vessel on the vessel would be 0.553. But for the reaction to go to completion, you can realize quickly that you need 3 times the amount of mole of hydrogen than the amount of mole of benzene for the reaction to occur. So the approach that gave you this result, it is not going to be correct. So now let's go ahead and see what actually is going to happen. So we are told that the initial pressure is equal to 0.378 atmospheres. And we're told that the final pressure is equal to 0.209 atmospheres. We know that this implies a change of pressure corresponding to a drop of 0.169 atmospheres. So now let's check what that drop corresponds to. Initial pressure is the pressure of benzene plus the pressure of hydrogen that we have. And the final pressure is going to be equal to the pressure of C6H12 of cyclohexane plus the pressure of hydrogen that did not react. So the one that was in excess. How do we know that? We know that the reaction goes to completion. So that means that since we have a one-to-one relationship in between benzene and cyclohexane, these pressures are going to be the same. So the only thing that causes this drop is the change of pressure of hydrogen. So the pressure of hydrogen that reacted is going to be equal to 0.169 atmospheres. If this corresponds to the reacted fraction, we know from the stoichiometric relationship that 3 moles of hydrogen react with 1 mole of benzene. So 3 mole of H2 corresponds to 1 mole of benzene. Let's turn this equal into a process because now we're going to get pressure of benzene that we had initially. How can we look at this? Well, if we multiply the pressure of reacted hydrogen by this coefficient, is the same as doing amount of mole of hydrogen that reacted times RT divided by the total volume multiplied by 3 mole of hydrogen times 1 mole of benzene. Moles of hydrogen are going to cancel out with moles of hydrogen, and we're going to end up with amount of mole of benzene that reacted times RT divided by volume, and this is nothing but pressure of benzene that we had initially. So, by dividing 0.169 over 3, we have the pressure of benzene, that is 0.05633 periodical, and the fraction of benzene then is going to be of C6H6, pressure of benzene divided by my total pressure at the beginning, so 0.05633 3 periodical over my initial pressure that was 0.378. Of course, this is in atmospheres since we did the calculation with all in atmospheres. And the result is 0.149, which you can approximate it to be 0.15. Now this result does make sense because we're told that we had an excess. So for having a fraction of 0.15, we need to have at least 3 times of hydrogen. So this would be the correct and final answer. Thank you very much and have a good one.